Hello, welcome. Let's continue our tutorial on mensuration 2. And in this episode, we are dealing with volumes, but the volumes of the prism will be taken in this episode. And we are going to develop the formula for calculating the volume of all prism if possible. So we are just going to talk about how do we develop the volumes of prisms. And by the end of this, you should be able to have fair idea of the volumes of all prisms. Now, what is prism? We talked about it before in the previous episode. Prisms are just three-dimensional geometric solid shapes or figures that has the same cross-sectional area or have the same end to be the same or similar. We have a rectilinear cross-section size to be parallelogram. All right. Now, how do we determine the volume? The volume is just the space that has been occupied by the prism. So if you take, for example, a cup made in form of a cylinder, the space in it, the amount of water that the cup will hold will determine the volume, the capacity of that cup. So let's see how we can relate that into a formula calculation. We know there are different types of prisms, right? We can start by talking about a cube, which is formed from a square. We can also have a cuboid, which is also formed from a rectangle. Yes, of course, we can have a cylinder, which has the name as a cylinder, not basically in terms of prism, but it's also an example of a prism. We can have a triangular prism. We can have rectangular prism. We can have pentagonal prism. Prisms are developed from the name of their base or their cross section. So let's just base on cube or even a cylinder to be able to find the volume. Let's see if I have this given to me. Let me just make an example of a cube, right? It looks like a cube, right? Good. Then we are taking this as the base. Now, if you want to know the amount of space occupied, you are going to look at how wide is the base or how narrow is the base. The narrower the base with the same height, when the base is narrow, the volume becomes smaller. When the base is enlarged, the volume becomes larger, meaning the space occupied becomes larger. And if I take the base here, what I am taking is what? A square. And if I want to know the relation here, it means I have to know the area of the base. So let's just say we are taking this as a box of cubes, sugar, whereby let's say we are arranging this. Here we have three cubes of sugar arranged. Then we have 1, 2, 3, 4. We also have four arrangements. So in this case, if you want to know the amount of cube of sugar that has been placed in this box, I am just going to count all of them. Or I can just say that 3 times what? 4. Give me the amount of what? Or the number of sugar that has been arranged. Alright. Now if I add another group to it, right? If I add another group, since they have the same cross section, the same number will be 3 in here, 4 in here. So here, if I want to find the total number of cube of sugar in there, I'll find the arrangement at the bottom, then arrangement at the top. Meaning, I'll find the area occupied by that cube of sugar at the bottom. Then in the second stage, I'll find the area again. So it is the first area plus what? The second area. Meaning, I could have just said that instead of multiplying them to get, what am I going to get? 12. If I add the 2, I should be getting what? 24. All right. So instead of adding the area, imagine we are adding the cube of sugar up to 7 layers. It means first area, second area, the third area. So instead of just saying this, I can say that the first is 1 cube, the second is the second cube. So there are 2 layers here. So I will just multiply the 2 layers here by the 4 layers by the 3, meaning 2 times this 4 times this 3. This will give us 8 times 3, and this will give us what? 24. But don't forget, the 4 and the 3 were the area we know. So this is the area, the length, the breadth. So this is going to mean how the arrangement of cube vertically will become the height. Then this is the breadth, this is the length. So I can have the breadth, I can have what? The length. So you can see in here that if I am looking for the volume, it is just the multiplication of the height, the base, and the length, which we can rearrange as length times the breadth times what? The height. So that is how we calculate the volume of a cube. Now, but since this is a prism, we are going to say that the first measurement was area. So if I am looking for the volume, it's just the area of the cross section times the height. So if the cross section is a square, as in this case, I should be having length times breadth. So length times breadth is the area of the cross section. Then I have times height. The volume formula is derived. Then let's say in the case of a cylinder, okay? In the case of a cylinder, you can see this is the area of the base, circle. So the group of circle will develop a height arrangement. So this will be the height, this will be the radius. So we are saying that the area of the cross section, if I cut this open, I'll get a circle. And what is the area of a circle? Area of a circle is what? Pi r squared. So if you are saying the cross section area times the height, volume of a cylinder will also be equals to the area, which is pi r squared, times the height, which is going to be the h. Do you get that? So no need memorizing the formula. You can just know that to find the volume of any prism, it is the area times the base, the height. So if it is in case in this form, as in what? The rectangular prism, a triangular what? Prism. Meaning, let's say, can I make that diagram? Okay, let's see. If I have this, I have this. So this, and this. Okay, so this is also an example of what? Triangular prism. What is a cross section? The cross section is what? The triangle. So we need to find the area here. So there will be a height. This is going to be the base. This is going to be the height. So this volume of a triangle will also be the area of the base, which is the cross section. We know it is half times the base times what? The height. And this height is the height of what? Of the triangle or of the base. So let's label that 1 times the height of the prism itself. And that will be the second height. So in case of a triangular prism, we are going to be multiplying the height, which is the height of the triangle, the base, by the height of the prism itself times the base times half. That's 0.5. Already we know the area of a triangle. So I believe you know what the area of a rectangular prism is going to be. The same as finding the area of the base, which is the length times breadth. Then multiply by the height, which will be the same as the volume of, let's say, a cuboid, which will be the length times the breadth times what? The height. So in this episode, we are only throwing light on the formula of the prism, that is the volume of a prism. Any prism, just find the base area, then multiply by the height, how tall or short the height is, then you are able to get that. Come back to this piece. Let's take questions differently on each of the aspects and see how we can do that. Thank you for watching. Like and share. Bye bye.